Everyone. Today I will be attempting Advent of Code 2025 day 1. We have about 33 seconds to go. I have a template structure that I provided for all of my files, so it's easier. Okay, let's just wait for it. Okay, cool. Let's see. So, emergency decorating the 12 post by December 12 grants 1 star. So I think a lot of these are the same setup that they always give. So I would probably just copy up the output, save it here, and let's just say that the dial is pointing sequence of rotations, one align, tell you how to open the save of rotation starts with L or R, whether it should be turned towards or left or right, and the distance in which it should turn. If it's pointing at 11, a rotation of R8 causes it to point at 9. Okay, so turning the dial from 0 makes it think. So just this property alone tells me it's going to be a modulus kind of operation. So the dial starts pointing at 50. Follow the instructions. The password is the number of times the dial pointing at 0 after any rotation in the sequence. Right? So we just want to check how many times it goes to 0. Cool. So let's just parse the line. So we say that rotations is an array. Maybe let me increase the size of this terminal. And the rotations is just the contents strip split by new lines. And we kind of want to convert these to proper numbers first. So if we return the rotations, what we want to do is for each rotation in raw in this, we would want to say a plus or a minus for the L or R. So we would do rotation 1 onwards. This would be the rotation itself. And then we would multiply by the sign, which is if -1 if the rotation raw at 0 is L, else it's 1, right? So for this, we should see a list of integers, and let me just print out the data. I also have a CLI that I built to support all of these operations, so I can very quickly test the various functions, and you can kind of see here, so -68 if it goes to the left, and if it's going to the right, it's +60. Cool. So you have the starting position, which is 50. You have the dial size, which is 99. No, which is, I believe, 100 actually. So you want to say that for rotation in the data, basically well, we say it's just the position. So you can say that the position is equals to the position plus the given rotation, and you can modulo by the dial size, right? And then if the position happens to be equals to 0, the number of times is at 0. So we can say that the answer is 0, and we can say the answer can increment by 1, and we can just return this answer. Cool. Yeah, so you can kind of see here, the answer pointed is 3, which is what we were given. So let me just copy in this example, and let me go with day1.txt, this day. Cool. And if I just run it without, it's 1180. Cool. All right. The second question is to use a password method until further notice. So you're supposed to count the number of times any click causes the dial, regardless of whether it happens during a rotation or the end of one. So essentially, we are interested in seeing if the rotation completes before completes with a 0 included in it. The way we can do it, if you want to just think of it as a proper dial, so if we just think of it as a single dial, we could simulate the back and forth movement, but I think that's a bit slow. So what I would think of in my head would be to say, okay, so let's just say the position is 50 again, the dial size is 100. You have the answer again for every rotation that's in the data. Position is equals to this if position, well, okay. So I think one of the ways this would happen is basically there is two ways this could happen, right? Either you're rotating right and you go past the so you rotate right past 0, or the second option is again rotate left past 0. When we rotate right past 0, we would always be increasing the number. So from a number x to a number y, we would always have the case where x becomes greater than y, because if it passed 0, it would have reset. In the same way, if number x is going down to number y, and you're rotating it to the, sorry, this is to the left. This is to the left. Yeah, so if I'm rotating it to the left, what happens is if it passes through, we should see the case where x is less than y, right? And then, so something like this. So I think so we can say new position is equals to this, right? And then we use the new position instead. So we say if the new position is, well, we say if rotation is less than 0, which means we are going left. The new position, if new position is less than the position, right? Yeah, the answer can increment by 1. Otherwise, if new position is greater than the current position, answer can increment by 1, and then we can return the answer. I'm not super sure if this is the correct approach, but yeah, so you see here it says it rotated it to 6. Yeah, okay. Yeah, so you can kind of see here, if you were rotating left, right? So if you started with 50 and you rotated left, what happened was it would go from 50 to 82. So if the new position is greater, let's see, if the rotation is less than 0, which means it moved left. If the new position is less than, it means it hit 0 once. I see. Otherwise, if the new position equals to 0, and then we can say that position equals the new position. Oops. Let's see, else if the rotation is greater than 0, if the new position happens to also be equals to 0. I think we cover the case by using the above. No, we don't. Okay, so we counted 1 extra. Why is this the case? Okay, maybe let's do a much simpler example, right? Because did they say that the number can be greater than 1 potential rotation? They did not. Well, I guess we could see if, well, 100 didn't exist. So I'm assuming that a person can't rotate more than the dial. Oh, they can. You see here, these are numbers that make it possible to rotate past the dial. Okay, so I'm trying to think, because now that you can rotate more than once, it might be difficult to to actually do it. So let's see. I guess one way we could do it is assuming the current point is considered x, and you rotate it to the right. There are a few key bits here. The first bit is if the rotation is greater than the size of the dial. What this implies is that it would pass through 0 multiple times, right? And the number of times it passes through the dial, passes through 0, would be, I think, the rotation over the dial size. So if I had an example where the dial is just 5 numbers, right? So if the dial size is 5, and my rotation, let's say it's 20, and the starting position happens to be dead smack in the center, which is maybe, let's say, 1, or I guess 0. It would be the case where we would rotate once for 5, and then it would become 4. Okay. I feel like we might be able to get away with just simulating this. Maybe let me do that first and then come back to a much more optimal approach later on. Because I realize that this is a bit more complicated than we really need it to be. Cool. So what we could do is, let's just say that for v, or I guess for I in range of the rotation, and because we are inclusive of a negative number, let's just do an absolute on this rotation. If rotation is less than 0, this means that we say that position equals to the position plus minus I, and then we modulo the dial size. Else we need to plus. So I guess this doesn't really matter. This will always be 1, and this will always be a plus. And then we just check if the position happens to be equals to 0, the answer can increment. So this is sort of the brute force approach. And it passed, so I think we didn't really need to optimize it too much. Cool. Okay, so I spent a bit of time thinking about this. And essentially, the idea previously was kind of right, where we should be thinking of this in terms of 2 different cases. So I've wrote down a very rough explanation here, but I'll just go through it in a bit. So there's kind of 2 properties that are guaranteed when we perform the kind of rotations, right? The first property is if you're performing a rotation from to the right, so long as you don't start or end at the 0 position, what happens is that the number, and it goes through the dial or to the 0, what happens is that the old start position becomes greater than the new start position. So in this case here, you could imagine a x is equals to, so the original number was 50. If the rotation was, say, 80, the subsequent y value would be, I think, 30, or a number that is smaller because it kind of went behind. And then if you're moving to the left, again, a case could be something like x is equals to 50. And if you're doing left 80, y would then exceed and in turn make it a much larger number because it would go behind it. So I think in this scenario it would be 69. I'm trying to think. So 50 plus 30 would be 0, and then you do 0 to 50 plus 50, and then you do 0 to 30. So yeah, it would look something like this. I think the numbers might be a bit off, but the fundamental idea here is so long as you're rotating, let me just type it out nicely here. You have the rules. You have the rules where the first rule is if you're rotating right past 0 and you don't start or land on 0, then the previous position is greater than the new position. And I think this is the A. If you look at B, if you rotate left past 0 and you don't start or land on 0, the previous position would always be less than the new position. Cool. The second kind of rule we can think of is if the rotation, or I guess if the absolute value of this rotation happens to be greater than 100, or the dial size. What this means is that we have kind of two guarantees here. We are always going to rotate around 0 at least once, right? And the kind of second guarantee that we have here is that if we take the excess, which you can think of it as the absolute of the rotation, so however much it has to be rotated minus the number of times it was already rotated, multiplied by 100, the excess. Sorry, so you take the previous position plus this excess modulus by the dial size is subject to 1, right? It's still subject to the first rule. So you kind of have two different rules that we set up here. The first rule, maybe let me shrink down the size here. The first rule we have is that if we are rotating right past 0 and you don't start or land on a 0, the previous position is always greater than the new position. And if you rotate left, it would be previous position is less than the new position. The reason why I say we don't start or land on a 0 is because we can handle those cases separately, where if you do land on a 0, we can count that as an additional case. So we kind of don't want to mix the two cases together. The second rule we can kind of come up with is the fact that if we are rotating more than the dial size, we are guaranteed to always have rotated past 0. So we can count those number of times first, and then calculate the excess. And the excess individually could also add another one to the rotation. So that is sort of the two rules we operate on. So we can kind of do several things. The first thing we can do is we can say that, maybe let me just organize it a bit better here. So you can kind of say, we can declare something called the exceed dial size rotations, where this is the kind of play against the first rule, where we calculate the number of times we are guaranteed to always go through 0, which is basically take the absolute of the rotations divided by the dial size. We then calculate the excess that is available to us. So if you never ever rotated past the dial more than once, this would just remain at 0. So we would just return the absolute of the rotation multiplied by the sign. So we can then calculate the new position. So we are kind of now back playing against rule 1, right? So this is rule 1, and this is rule 2. So once we calculate rule 1, we can say that the new position is just the current position plus the excess modulo by the dial size, with the excess past 0 is whether or not this number has satisfied the first rule. And so we can check if we are doing a left rotation and both the new and old positions don't start at 0 or land at 0, and we see that the old position is less than the new position, we know that we have guaranteed past the 0 once. The other alternative is if you're moving right and we see that the new position is greater than the old position. The last sort of rule that we have is if you do land, or I guess like an additional thing is if the new position does land exactly on a 0, it would not have been caught by these two rules. So what we want to do is we want to include it as well. And so the subsequent answer is just the number of times it takes to rotate an excess, the number of times, whether or not the excess does rotate past the 0, and whether or not this new rotation lands on a 0 specifically. And that's sort of remains the solution. So you can kind of see here, if I just run the CLI on the part2, we produce the same answer as the previous one. So this is sort of a slightly more efficient method of doing it. Rather than simulating every position on the dial, we perform some kind of math where we calculate mathematically the number of times it has to pass zero. But cool. Thank you so much for watching this.